Hello and welcome to the Smooth Scaling podcast, where we speak with industry experts to uncover how to design, build, and run scalable and resilient systems to ultimately provide a great customer experience. I'm your host, Jose Quaresma, and today we have Martin Jensen with us. He's the head of engineering here at Qubit, and we'll be talking about the costs of scaling for peak demand. We talk not only about scaling and kind of auto scaling, pre-scaling, but also other tools and mechanisms that can be leveraged to complement that and to work together to address peak demand. Of course, we are a little bit biased, so we did get a bit into virtual waiting rooms and how they also can help in peak demand scenarios and what other things they bring to kind of to a system. Hi, Martin. Welcome.
Thank you. Thank you, Jose.
It's great to have you here, and would maybe like to. So we're going to talk about costs of scaling and kind of a few things around that area. But I would like to start maybe by having a little introduction from you, a little bit of your background. How did you got to be a head of engineering at Qubit?
Yeah. So I have about 20 years of experience in the IT industry, first as a software developer and later as a manager, engineering manager. I spent a good deal of time in the financial sector where I worked with a lot of different things, among them online trading, which also speaks into large-scale systems and high-demand systems. Later on, I worked for another Danish scale-up company, also with some very heavy load on the back end. And that sort of got me here into Qubit, where I'm now head of engineering and enjoying the work a lot.
We're happy to have you.
Thank you.
So maybe starting to go a little bit into our topic today, we're kind of covering costs of scaling for peak demand, right? So maybe we could start. How do you think about peak demand?
Yeah, so most websites will have a fairly even demand throughout the day in whatever region that site might have most of its customers. But sometimes some sites will have these peak demand events where suddenly you see a lot of traffic on the site, much more than you would normally see on the site. So that's what we define as peak demand.
Okay. So not so much the absolute value of the traffic, but more like what's the difference from your baseline traffic in the website to now we all of a sudden got way up here.
Yeah.
So that's what you got.
Yeah, so if you look at the graph, you can imagine it's like a reverse icicle, sticking out of the graph. That's what we define as peak demand.
Okay. So if it's something more slowly growing and almost organically, that we wouldn't count as peak demand, right?
No, that's not. No, that would be normal growth.
Yeah.
Yep.
Can you think of or share some of examples of kind of this peak demand that?
Yeah, so I think one of the sort of very classic examples would be, for example, ticketing sales for concerts. Usually these are announced to go live at say 10 in the morning in a region, and then people are going to jump into their browsers and start hitting the site at maybe just before 10, and that means you can actually see an increase in traffic going from the base traffic to X 10 100 in a very short amount of time, and that's like in that we're talking in within a minute or even in some cases within seconds.
Yeah.
So that's going to definitely be felt like a very high peak demand. In other cases, it might be commercial sites that have drops of specific things. It might be, you could have so many announcements that would lead people into a specific commercial site. You can also have government institutions, public institutions have signups. So there's a lot of different scenarios where we see these things happening.
Yeah. And would you say that they are all always predictable, or would you have some peaks in some cases that they're also unpredictable?
So in some cases, I would say some of them are predictable. They would usually not be predictable based on data, but they would be, so for example, traffic data, because there's not necessarily a pattern there, but they would be predictable in that, a company knows when it has sales starting, for example, for a ticket. So in those cases, it can be predicted. In other cases, less so. So for example, I think the example of a SoMe post suddenly attracting people to a specific website or web shop, that's something that can be difficult to predict, right?
Yeah, that's a good point. And so if one is then kind of trying to address peak demand, handle peak demand, what are for you some of the strategies to I guess handle such events?
Yeah, so the most important recommendation on this is scaling. We recommend that whenever you have a traffic with a substantial amount of a website with a substantial amount of traffic, that you design it in a way so it can scale with the traffic. That can be done in multiple ways. You can do it vertically, which it means buying bigger hardware, or you can do it horizontally, which means you will scale out. We recommend, and this is also sort of the most modern approach, to do it horizontally, but that requires that you architecture for that. So it's a little bit more of a complicated architecture, but it scales better. That would be the most important advice. It doesn't necessarily handle all situations, but it will definitely handle sort of the slow growth, the steady growth on the site. So that would be our main recommendation.
And you just said it doesn't necessarily handle all situations. So I guess what I'm hearing is it will not solve everything, right? So
No.
what are some of those situations where the kind of the auto scaling approach, whether it's vertical or horizontal, is not enough?
Yeah. Horizontal scaling is based on cloud architectures, and in cloud architectures you can scale out quickly. Unfortunately, not quickly enough to handle all situations. So, for example, you can imagine that these ticket sales, when they go live, as we talked about before, you will see an increase in traffic within seconds, an extreme increase in traffic within seconds. And adding servers to a web farm, for example, that is not done in seconds, that's done in minutes, right? So scaling up takes time.
Yeah.
There's also other pieces of the architecture, so caches, for example, that needs to be scaled up and also prepared. And it's not something that you can do instantaneously, which is kind of what these kinds of events require.
Yeah. And I guess there's also the other side, because we talked about are these peaks predictable or unpredictable, right? And I guess on the predictable side, there would also be an approach more towards pre-scaling, right? Is that something that you see working well as well? Kind of, are there any downsides?
So pre-scaling is something that you can do. So if you know that you have an event coming, for example, right? Then of course you can prepare for it by pre-scaling. The problem there is that first of all, it can be expensive because you're scaling up, and you're not going to have a constant load. So that means you will be optimizing for your max load, which might be only for a short amount of time, right? But if you don't have that capacity at that time, then you might crash your site. So you still need to do it in a way. So that means it can be costly, basically. The other thing is that it's usually easy to scale up, for example, your web servers, which is sort of on the front line of your whole architecture. But when you're let's say you're in a ticket sales scenario, then you will have many components within your architecture that need to take part of that. You'll have you might need people to log in. You will probably need people to pay for the tickets. So there's going to be a lot of components, and you need to be able to scale all those.
Yeah.
And that's not always possible. They don't always have the same scalability features. Some of them might be third-party components. Some of them might be based on older architectures. There are many situations, many companies that don't really have architectures where all components scale equally.
Yeah. Okay. And what can they do in that case?
So what we recommend is to in that case control the traffic by putting in a virtual waiting room. Basically, you need to understand what is the capacity of your architecture, not just on the front end on the web service, but in the full flow of the for example the ticketing situation, and then use the waiting room to control the flow of traffic onto your web servers, and then aim for something that is maybe not at but just below your ideal capacity.
Yep.
And that way could make sure that there's a constant flow, and also that the users, while they're waiting to get in, are informed of where they are in the queue, so that they don't panic and they have a good buying experience also while waiting.
That's a good point. But would you say that we're talking about cost, right? And so even if people out there are definitely cases where you could say that the full user journey and infrastructure and is kind of fully scalable.
Mm-hmm.
And I guess you could say limitless, because you're in the cloud. So I guess there's a theoretical limit to the data center size, but they could just kind of confidently scale all that they need. Would you say that there's still how would you suggest people to think about kind of the balance between auto scaling towards kind of other mechanisms such as virtual waiting room? Is that a cost analysis on saying, well, even if I can scale all that I need and fast enough for pre-scale, but then should I do that because it might get impossibly expensive? Is that how you see that?
Yeah, I mean, I think those two technologies complement each other. You kind of need both of them if you have peak situations. So you want to, of course, make sure that you have that you can scale, because scaling is also a way of keeping resources down, because you're not always going to have the same load on your web service, right, or on your system. So you want to make sure that when you do have lower traffic, that you also scale down.
Yeah.
Then when people get online and start hitting your web service, then your web service scale up. So that's something you would want in any case. And then you would always probably want to optimize for this, I guess, ideal load, where you have where you sort of have a that that you can measure in your system. But then you would also want the waiting room to make sure that when you do have peaks, then the waiting room kicks in and then protects your system from crashes. And that can be both expected events, but it can also be unexpected events that you didn't see coming.
Yeah, and in that case, you could have like the flow, the traffic going into the website. But if you all of a sudden see a peak, then you're saying that the waiting room can kick in and protect your infrastructure.
Yes, exactly.
Yeah. That balance does make sense. Would you see? What are kind of the most common misconceptions or challenges when using auto scaling?
So there's a few. We've been talking about the cloud for a long time, and there's definitely some promises that came with the cloud that to some degree has been fulfilled, but it's not magical. It's it can sometimes seem like it, but it's not. There's at the end of the day, somewhere in the cloud centers, there's also physical computers.
Yeah.
So there are restrictions, there are limitations that you need to keep in mind. And for example, when scaling up, it's not given that you can scale up limitlessly.
Yeah.
There's going to be limits. You might need specific types of instances of servers that are in high demand, maybe. There's also many components in an architecture often, and they might have different kinds of limitations. So if you have some serverless processing going on, then maybe there's some limitations on there that's not going to scale easily or as much as you need it to. And there's still networks, so there's still networking within the infrastructure that you need to also, and the networks has limitations as well. It has bandwidth limitations. So there are many things that can still go wrong, and that can still limit your architecture. In any case, whenever you have when you have an application like a web shop, for example, or any kind of software application, there's always going to be a bottleneck somewhere.
Yeah.
Right. It's a matter of where's the bottleneck, right? And that also goes for systems in the cloud.
Yeah. And from a bottleneck perspective, I think you referred to it before, kind of the external dependencies, right? I think you talk about payment systems, for example, or some of the others. If you look more kind of internally to what's within one's control in one's kind of infrastructure landscape, do you have a feeling for experience or kind of where are the bottlenecks more often?
Oh, I mean, I've seen a lot of bottlenecks in my time. So it can be in many different places, right? I mean, sometimes something we often see, especially so let's go with architecture, for example, that have some older components. It might be systems that were built over many years, tens of years. That might be an old database somewhere. That can be a bottleneck in many ways. It might be other components that are critical to the business, but encapsulate some kind of business logic that sort of has been the core of the business for many years, right? It can be it can be many things, and there's always it's just always going to be somewhere in your chain of processing. There's going to be something that will be the slowest point.
And often it feels like it's if you do want to kind of increase the performance of your system for peak traffic, then it's often kind of you look at it, you find the bottleneck, and then try to improve the performance of that bottleneck. But then there will be another bottleneck, right? So there's I guess a never-ending exercise there.
Yeah, exactly. Yeah.
Going all the way back to theory of constraints and all.
And sometimes these bottlenecks will show up under different, in different situations, right? So you might suddenly see behavior of database start changing when it reaches a certain, a certain load.
Yeah.
Or it might be that suddenly we're hitting something in the database that's not optimized, and that's going to cause a bottleneck to appear. And that can have a downstream effect or an upstream effect on other systems if this happens.
So, kind of what I'm hearing you say, and correct me here if I'm wrong, is that autoscaling is an important part of your kind of one strategy for handling traffic into one system. It's kind of necessary, but not sufficient, right? So it's to be taken as part of a whole, as a strategy on how to address these, and maybe trying to kind of also zoom out a little bit. That we talked about kind of autoscaling and virtual waiting rooms as being a good complement to each other for handling peak demand. Are there other tools, mechanisms that you could see in one's infrastructure toolkit that would also should be used?
Yeah. So there's definitely sort of the classic components that you will often see in a well-built website. So you can have CDNs, of course, that will for your static resources. That will move those resources closer to the users.
Can you can you explain to maybe there's someone listening or watching us that maybe doesn't know what a CDN is?
So the CDN is short for content delivery node, just to get that out of the world. Basically, what they are is that in the cloud environments, these will be located as nodes close to geographic locations, so that no matter where you are in the world, you're probably going to be close to one of these CDNs.
Yeah.
And then what you can do is you can put your static resources, so that would be images, for example, or files like static text files, on those. So basically, all the content that doesn't need processing on the web servers.
Yeah.
And they can be then cached there and loaded and downloaded closer to the user. So that speeds up the whole web viewing process. Then we have caches. For example, you will usually have caches in front of your critical components in your architecture. They will also, so that can be, for example, if you have, let's say you're a web shop and you have some item that's super popular that people search for all the time, then you can cache the search. So that your web service don't need to run that query every time. It's just to say, okay, these sneakers, they're super popular right now, so we can see when customers search for it, so we're just going to return this prepared response, right? So those are definitely things that we also recommend that you use heavily in your architecture.
And it sounds like some good tools to bring in. Maybe not simple tools, right? In my experience, also caching is something that is there's quite some important details on how the caching is working, and if you're not careful with that, you think that you're caching content, but in the end you're not, and your server is actually getting hit by it, right? So
so caching can be a little bit complicated, for sure. I think CDN is pretty simple. That's just storing things closer to
on
people.
the edge,
On the edge, yeah. Caches definitely come with a little bit of a complexity. But I think these days the technology is definitely there. So it's a question of using it in a good way.
Maybe just you referred to virtual waiting rooms and how they can kind of complement scaling in a kind of addressing peak demand. Can you tell us a little bit about how is it that they can be integrated in someone's infrastructure? And then also if you think that, and we can get back to that, if there's other advantages than just helping controlling the flow and the cost.
So let's say you have a website, like a commercial website, and you have your ideal load defined. Then what you do is you create an integration layer in your own infrastructure that once traffic starts going above your ideal load, you will start sending new traffic to this waiting room component, right? It's all handled at the HTTP level, so there's no sort of magic in it. You would forward, basically forward HTTP requests to the waiting room component, and that will then handle the whole queuing functionality.
Yeah. And that we've kind of seen working best at the edge, right? So we have different ways of setting it up, server side, client side, but I think our experience at the edge is where it works best.
Exactly, because that's where you have your traffic. It's also it's within your architecture, your system architecture. So that means it's you can't really, or bad actors can't really cheat. So that is the best location to handle that. Then what you do is basically, because you understand what is your ideal load, you can also define, so what is the rate at which you want traffic to enter your site. Probably, let's say you're in a ticketing situation, you have a rough idea of how fast people go in, find their tickets, and then pay for them and get up and move on. So that means you can then set up your waiting rooms just forward
Yep.
the waiting customers into your site.
Yeah.
So it's actually very simple, and it's all based on HTTP, and it helps you throttle the rate of customers entering your site.
Yeah. And one thing just to add from my side that I've learned that it was maybe not unexpected, but something that I hadn't maybe thought so much about before I kind of faced that with some of our customers, that flow and that optimal rate going through isn't always the maximum that the website can handle.
No.
And I think that was quite interesting to think about. And when you think about it, like, oh, that's obvious. But sometimes it's more about if you have very limited supply of an item, like maybe at the limit, I mean, if you're selling something in your web shop that you only have 10 of, and if you have, maybe your website handles 1,000 people coming in, but then it's actually not a great user experience if 1,000 people are trying to reserve and buy those 10 items, right? So then the rate that you want to get in the website then is actually not limited by the performance of your website, but more closer to the items that you have, and you're trying to avoid having as many clashes as possible when reserving items. So that was something that it was a little click on my mind, like, okay, yeah, that makes a lot of sense. But I was always thinking more about performance and how much is the max. So that was quite interesting.
Yeah, definitely. I mean, so sometimes the bottleneck is not even the technology, right? It's the product.
Yeah.
Yep.
And are there other things? So here we're talking about peak demand and how this complements CDNs and the scaling part. But what would you say are the other kind of main upsides of having a virtual waiting room as well?
So it means that you know how much traffic you're going to get on your site. So there should be no surprises.
Yeah.
Right. That's the deal. And I think that's really what the main upside is here, because as long as you're walking into unknown territory, a lot of stuff can happen that you didn't expect, right? So there's a lot of it. It's these web setups are complicated. They can be a lot of different components, and testing for everything can be very difficult and costly.
Yeah.
So in that sense, it's you kind of know what you're getting.
Yeah. I really like this idea of kind of being in control of the situation. Then also think another interesting point or important point with virtual waiting rooms is the kind of think about human psychology and I guess queuing psychology. So how people feel about queuing, kind of this idea that you can be very transparent with people on how many people are ahead of you, what is the expected wait time. That's something that psychology studies shows over and over again, that it's very important for people to know how much they have to wait. So I think that's something that is kind of quite an added benefit of having a virtual waiting room and being able to control and predict that.
Oh yeah, definitely. Yeah. And also, I mean, you can also you can change the rate of how fast customers are then moved on to the website, right? So if something unexpected does happen, you can also use the waiting room to slow down traffic. Yeah. But still have customers waiting in this safe environment, right?
And maybe to thinking about kind of wrapping up a little bit, I think we covered quite nicely kind of how to handle peak demand, focusing on kind of scaling, both auto scaling and pre-scaling, and the consideration cost. Are there any kind of practical tips that you would give to people kind of considering kind of how to control the scaling approach? Anything that you would like to?
So definitely make sure you have metrics in place, understand your architecture and your system, right? You can't go blindly into these things, so you have to understand what's your max load, or what's your capacity, and what is your sort of desired load, which is probably going to be, maybe, some way from your max capacity, because you don't want to go there. I think that's the most important thing, understanding, and then having, a high level of transparency. So having good dashboards, having good metrics, where you can see for all your critical components, how are they doing, and react if something is out of the ordinary in tense situations, right?
Yeah, very good. Thank you, Martin, for coming by. It was great. I've learned quite a bit around scaling and kind of how we focus on handling peak demand.
Thank you.
Thank you. And that's it for this episode of the Smooth Scaling Podcast. Thank you so much for listening. If you enjoyed, consider subscribing and perhaps share it with a friend or colleague. If you want to share any thoughts or comments with us, send them to smoothscaling@kiwit.com. This podcast is researched by Joseph Thwaites, produced by Perseo Mandilo, and brought to you by Kiwit, your virtual waiting room partner. I'm your host, Jose Quaresma. Until next time, keep it smooth, keep it scalable.